Welcome to Mastering Next.js SSR, from foundations to edge deployment. I'm your instructor, and over the next 42 minutes, we'll transform you from someone who knows basic Next.js into a developer who can build production-grade, high-performance e-commerce applications using server-side rendering. You'll master the complete spectrum, from foundational Node.js patterns and TypeScript safety through modern app router data fetching and streaming, all the way to securing your app with middleware and deploying to the edge. By the end, you'll confidently refactor any client-side rendered e-commerce page into a fully server-side rendered powerhouse. Here's your learning roadmap. We'll cover 3 essential modules. Module 1, Quick Foundations, will establish solid Node.js basics and modern TypeScript patterns that form the backbone of robust Next.js backends. Module 2, Core SSR in Next.js. This is where we dive deep into data fetching strategies, from legacy getServerSideProps to the modern app router, plus advanced techniques like streaming with React Suspense. Module 3, Middleware and Edge Functions, will secure and optimize your applications using middleware for authentication, redirects, and geo-targeting. Then deploy everything to the edge for maximum performance. Each module builds on the previous one, taking you from foundations to production deployment. Let's start with the foundation. What is Node.js, and why does it matter for Next.js SSR? Node.js is a JavaScript runtime that lets you run JavaScript on the server, not just in the browser. Think of it as the engine that powers the server-side part of your Next.js application. When a user requests a page, Next.js uses Node.js to execute your server-side code, whether that's fetching data from a database, calling external APIs, or rendering your React components into HTML before sending them to the browser. This server-side execution is what makes SSR possible. Without Node.js, Next.js would just be another client-side React framework. Now let's understand the core mechanics. The event loop is Node.js's secret weapon. It handles multiple requests without blocking. While one request waits for a database query, Node.js can process other requests. This non-blocking behavior is crucial for SSR performance. Next, modules. Node.js supports both CommonJS, require module.exports, and ES modules import-export. Next.js primarily uses ES modules in the app router. Finally, async operations. You'll use async await patterns constantly in SSR, fetching data, calling APIs, reading files. These 3 concepts, event loop for performance, ES modules for modern syntax, and async await for data operations, form the foundation of every Next.js server-side function you'll write. Let's see this in action with a simple HTTP server. Here's the code. Import wcreate-server from HTTP. The server listens on port 3000 and responds to any request with hello from Node.js. When you run this, you have created a basic web server that can handle multiple requests simultaneously thanks to the event loop. Notice the async pattern. We are using ES module imports, and the server handles requests without blocking. This is exactly what Next.js does under the hood, but with much more sophistication. It creates an HTTP server, listens for requests, and uses React to render your components into HTML responses. This simple example shows the foundation that makes all Next.js SSR magic possible. Now, let's talk about the why behind type safety in backend logic. In server-side code, bugs are more dangerous than client-side bugs. A client-side error affects one user. A server-side error can crash your entire application for everyone. TypeScript acts as your safety net, catching errors before they reach production. It ensures your API routes receive the expected data types, your database queries return the right structure, and your components get the props they need. Without TypeScript, you're flying blind. You might pass a string where a number is expected, or forget to handle null values from your database. In e-commerce applications, these bugs can mean lost sales, broken checkout flows, or security vulnerabilities. TypeScript prevents these issues by enforcing contracts between your code components. Here's your first essential pattern: typing API route handlers. In Next.js, you import Next API request and Next API response types to ensure your handlers are bulletproof. The request type tells you what data you can expect: query parameters, request body, headers. The response type ensures you're sending back the correct data structure. Here's the pattern: export default function, handler req, Next API request, res, Next API response. But we can be even more specific. If your API returns product data, create an interface like product response and use Next API response product response. This way, TypeScript will catch if you try to send back the wrong data structure. Your IDE will autocomplete the available properties and you'll catch bugs at compile time instead of runtime when customers are trying to buy products. Now let's apply the same principle to server components. In the app router, your page components receive props containing data fetched on the server. Without types, you're guessing what data structure you will receive. Here's the pattern: define an interface for your component props. For example, if you're building a product page, create interface product page props with properties like product, reviews, review, and related products product. Then your component becomes export default function, product page, product, reviews, related products, me, product page props. Now TypeScript knows exactly what data this component expects. Your IDE will autocomplete product.name, product.price, and catch typos like product.title. This prevents runtime errors when your component tries to render undefined data, which would show blank pages to customers. Let's see these patterns working together in a complete example. First, we have our API route at API products id.eth. It uses Next API request to get the product ID from the URL, fetches the product from our database, and returns it using Next API response product. The product interface defines our data contract, ID, name, price, description, and image UL. Next, our server component at app products id page.xx outxx. It's an async function that calls our API route, gets the typed product data, and passes it to the component. The component props are typed with product page props, which expects a product of type product. Now everything is connected. Our API guarantees it returns product data, and our component guarantees it can render product data. TypeScript ensures this contract is never broken, preventing bugs that would show error pages to customers trying to view products. Perfect. You now have the essential foundations. You understand how Node.js powers Next.js SSR through the event loop, ES modules, and async operations. You've learned to create type-safe API routes using Next API request and Next API response, and type-safe server components with proper prop interfaces. These TypeScript patterns ensure your server-side code is bulletproof and prevents the kind of runtime errors that break user experiences. These foundations are crucial because everything we build next, from data fetching strategies to streaming and middleware, relies on these core concepts. Ready to dive into the heart of SSR? Let's explore how Next.js actually fetches and renders data on the server. Welcome to the core of SSR. Let's start with getServerSideProps, often abbreviated as GSP. This is the traditional way to implement server-side rendering in Next.js's pages router. When a user requests a page that uses getServerSideProps, Next.js runs this function on the server at request time, not at build time like getStaticProps. It fetches data, then renders your page component with that data and sends the complete HTML to the browser. This means users see a fully rendered page immediately, perfect for dynamic content like user dashboards or real-time product listings. While the app router offers newer approaches, understanding getServerSideProps is crucial because many existing applications still use it, and the concepts translate directly to modern patterns. Here's how the getServerSideProps lifecycle works. When a user clicks a link or types a URL, the request hits your Next.js server. Next.js sees that this page has a getServerSideProps function and immediately calls it. This function runs completely on the server. It can access databases, file systems, or internal APIs that browsers can't reach. Once getServerSideProps finishes fetching data, it returns props to your page component. Next.js then renders your React component on the server using those props, generating complete HTML. Finally, this HTML is sent to the user's browser. The key characteristic is that this is blocking. The user waits for all data fetching and rendering to complete before seeing anything. This ensures they get a fully formed page, but it can feel slow for complex data operations. Let's see getServerSideProps in action with an e-commerce product page. Here's the code: export async function getServerSideProps context. The context gives us access to the URL parameters. In this case, context.params.e contains the product ID from the URL like aproducts h123. We use this ID to fetch the product from our database or API. Const product await fetch product context.params.id. If the product doesn't exist, we can return a 4R1. If it does exist, we return it as props, return props, product redirect e. Our page component then receives these props. Export default function product page. The component can immediately render product.name, product.price, and product.description because the data was fetched on the server. Users see a complete product page instantly, which is great for SEO and perceived performance. Now let's explore the paradigm shift in Next.js app router. Instead of special functions like getServerSideProps, the app router embraces a more intuitive approach. Data fetching happens directly inside your React components. This is possible because app router components are server components by default. They run on the server, not in the browser. You can make any component async and use await to fetch data right inside the component function. This eliminates the separation between data fetching logic and component logic that existed in the page's router. Your component becomes both the data fetcher and the renderer. This approach feels more natural to React developers and provides better co-location of related code. It's also more flexible. You can fetch data at any level of your component tree, not just at the page level. Here's the basic pattern for app router data fetching. Your page component becomes an async function, export default async function product page. Inside this function, you use await fetch to get your data, const product await fetch, ap products, id23ds. Then you can immediately use this data in your JSX return h1 product .name h1 bot. Notice how clean this is. No separate getServerSideProps function, no complex prop passing. The data fetching and rendering happen in the same place. This pattern works for any server component, not just pages. You could have an async reviews list component that fetches reviews or an async recommended products component. Each component manages its own data requirements. This modular approach makes your code more maintainable and easier to understand. Now let's talk about caching, one of App Router's most powerful features. Next.js extends the native fetch API with intelligent caching options. By default, fetch requests are cached, but you have fine-grained control. For dynamic data that changes frequently, like user-specific content or real-time inventory, use acache, no stores, to fetch fresh data on every request. For data that can be cached but needs periodic updates, use a next.ee revalidate 3600 bdop to cache for 1 hour, then refresh. This is incremental static regeneration (ISR) at the fetch level. You can even combine these strategies in the same component: cache product details for an hour, but always fetch fresh inventory counts. This caching system gives you the performance benefits of static generation with the flexibility of server-side rendering. Let's explore parallel and sequential data fetching patterns. The waterfall approach fetches data sequentially. First, await the product, then await the reviews. This is simple but slow. If each request takes 200 mems, you're looking at 400 mems total. The parallel approach uses promise.org to fetch multiple resources simultaneously: const product, reviews, await promise, or fetch product id, fetch reviews id. Now both requests run concurrently, and your total time is just 200 ms, the time of the slowest request. For e-commerce product pages, you might fetch the product details, customer reviews, related products, and inventory status all in parallel. This dramatically improves page load times. Use sequential fetching when one request depends on another, and parallel fetching when requests are independent. Here's a critical problem in SSR. What happens when one data request is extremely slow? Imagine your product page needs to fetch product details, fast, customer reviews medium, and AI-generated recommendations very slow. With traditional SSR, the entire page waits for the slowest request. Users see nothing until everything is ready. This creates a poor user experience where customers stare at blank screens for seconds. The AI recommendations might take 3-5 seconds to generate, but users want to see the product details immediately. This blocking behavior is the fundamental limitation of traditional SSR approaches. The solution is to send the page in pieces as data becomes available rather than waiting for everything to complete. This is where streaming comes to the rescue. Streaming solves this by sending UI as it becomes ready rather than waiting for everything. Here's how it works. When a user requests your product page, Next.js immediately sends the page shell, the header, navigation, layout, and any fast-loading content. Then, as different data requests complete, Next.js streams in the content for those sections. Users see the product name and price immediately. Then reviews appear when that data loads, and finally the AI recommendations stream in when ready. This creates a progressive loading experience where users can start engaging with the page while slower content loads in the background. The key insight is that not all content has equal priority. Users need product details immediately, but they can wait for recommendations. Next.js and React make streaming possible through React Suspense and the loading.xx file. React Suspense is a component that declares a loading boundary. It tells React this content might take a while to load, so show a fallback UI while waiting. In Next.js app router, you create a loading.xx file in your root folder, and Next.js automatically wraps your page in Suspense with that loading component as the fallback. When your async server component is fetching data, users see the loading UI. Once data arrives, React replaces the loading UI with your actual content. This happens seamlessly on the server. The HTML stream updates in real time. The beauty is that different parts of your page can have different loading boundaries, each streaming in independently. Your product page layout renders immediately with the product name and price. This is fast data. But you have a recommended products component that calls an AI service and takes 3 seconds. Without streaming, users wait 3 seconds to see anything. With streaming, you wrap recommended products in Suspense, Suspense fallback. Recommendations, skeleton, skeleton. You also create a loading.x file that shows a skeleton UI. Now here's what happens. Users immediately see the product details and a skeleton where recommendations will appear. After 3 seconds, the skeleton smoothly transitions to the actual recommendations. The page feels fast because users can read product details, scroll through images, and even add items to cart while recommendations load. This is the power of streaming, turning blocking operations into background operations. When should you use streaming? The benefits are faster. Time to first byte. Users see something immediately instead of waiting for all data. It also improves perceived performance. Pages feel faster even if total load time is similar. However, there are trade-offs. Streaming creates more complex UI states. You need to design loading skeletons and handle progressive content appearance. There's also potential for layout shifts if not handled carefully. Use streaming for non-essential or slow-loading content like recommendations, user-generated content, or analytics data. Don't stream critical content that users need immediately, like product prices or availability. The key is identifying what content is essential for the initial user experience versus what can load progressively. This strategic thinking separates good developers from great ones. Excellent. You've mastered the core of SSR in Next.js. You understand the evolution from getServerSideProps in the pages router to the more elegant app router patterns. You've learned to fetch data directly in async server components, control caching strategies, and optimize with parallel requests. Most importantly, you've discovered how streaming with React Suspense transforms user experiences by prioritizing critical content. These skills give you the foundation to build fast, scalable SSR applications. Next, we'll take your applications to the next level by adding security, personalization, and global performance through middleware and edge functions. Ready to secure and supercharge your SSR apps? Let's dive into authentication strategies for SSR applications. You have two main approaches: session-based authentication using cookies and token-based authentication using JWTs or similar tokens. In session-based auth, the server stores session data and sends a session ID cookie to the client. The cookie is automatically included in subsequent requests, making it perfect for SSR where the server needs to know who the user is on every page load. Token-based auth stores user data in the token itself, which is typically stored in local storage or sent as headers. While tokens are popular in SPAs, cookies are often simpler in SSR contexts because they are automatically sent with every request, no JavaScript required. For e-commerce applications, cookie-based authentication provides seamless user experiences across page navigations and is more secure against XSS attacks when configured properly. Next.js middleware is your secret weapon for implementing authentication. Middleware is code that runs before a request is completed. It intercepts every request to your application and can modify the response or redirect users. Think of it as a security guard at the entrance of your application. You create a middleware file at the root of your project, and Next.js automatically runs this code for matching routes. The power of middleware is that it runs on the edge, meaning it executes close to your users globally with near zero latency. For authentication, middleware can check for auth cookies, validate sessions, and redirect unauthenticated users to login pages, all before your page components even run. You can also use the matcher config to specify exactly which routes should be protected, giving you fine-grained control over your application security. Let's see authentication middleware in action. Here's your middleware.ts file. Import HP spawns from Next.js server. Your middleware function receives the request object and checks for an auth cookie, const token request, .cookies.getValue, value. If there's no token, you redirect to the login page, return next response.redirect new URL login request @al. If the token exists, you let the request continue, return next response.next. The matcher config specifies which routes to protect. Export const config matcher dashboard bath match bath admin bath me. This protects all dashboard and admin routes while leaving public pages like the home page unprotected. When users try to access dashboard orders without being logged in, they're automatically redirected to login. Once they authenticate and get the auth token cookie, they can access protected routes freely. This creates a seamless security layer that works across your entire application. Redirects are a fundamental part of web applications, and Next.js provides powerful server-side redirect capabilities. The redirect function from Next navigation allows you to programmatically send users to different URLs from server components and server actions. Unlike client-side redirects that happen after the page loads, server-side redirects happen before any UI is streamed to the client. This is crucial for SEO and user experience. Search engines and users are immediately sent to the correct location. You can use redirects for URL migrations, A/B testing, feature flags, or conditional routing based on user data. The key requirement is that redirect must be called before any UI rendering begins. You can't redirect after starting to stream content. This makes redirects perfect for early decision making in your application flow. Here are two common redirect scenarios. First, URL migration in a server component. Imagine you've changed your product URL structure from products HU123 to shop products HU2023. In your old product page component, you can redirect users, import redirect D from Next navigation, then redirect shop products each plus product data. This ensures old bookmarks and search engine links work seamlessly. Second, the authentication redirect we saw in middleware. When users try to access protected routes without being logged in, middleware redirects them to the login page. Both scenarios demonstrate the power of server-side redirects. They happen instantly without any client-side JavaScript, maintain SEO value, and provide smooth user experiences. The key is identifying where in your application flow these redirects should happen. Middleware for global concerns like authentication, and server components for page-specific logic like URL migrations or feature availability. Geo-targeting opens up powerful personalization possibilities. When you deploy to platforms like Vercel, they automatically inject geographic information into your requests through headers like xvercel if country. In Next.js middleware, you can access this data through the request.geo object or specific headers. This gives you the user's country, region, city, and even coordinates in some cases. The magic happens because this detection occurs at the CDN level before your application code even runs, making it incredibly fast. You can use this information to customize content, redirect users to region-specific pages, show local currency and pricing, display relevant shipping options, or comply with regional regulations like GDPR. The key insight is that geo-targeting works best when combined with other middleware features. You might check authentication and location to provide personalized experiences. Let's implement geo-targeting for an e-commerce site. In your middleware, you check the country code from the request const country request.geo country request headers getExvercel if country. Based on the country, you can rewrite the URL to show region-specific content. For US users, if country US is, return next response.rewrite new URL us plus request.nextRly bathname request only. For German users, if country DE, return next response.rewrite new URL dd plus request not next rlet bathname request rless. This means when someone in Germany visits products, they actually see D products with Euro pricing, German language, and local shipping options. When someone in the US visits the same URL, they see us as products with dollar pricing and US shipping. The beautiful part is that this happens transparently. Users see the same URL but get localized content. You can also combine this with authentication to provide personalized, localized experiences for logged-in users. Now let's understand the edge, a game-changing deployment paradigm. Traditional serverless functions run in specific data centers, often far from your users. When a user in Tokyo hits your app hosted in Virginia, they experience significant latency. The edge solves this by running your code on a global network of servers close to users. Instead of one data center, your code runs in hundreds of locations worldwide. Edge functions start almost instantly. No cold starts like traditional serverless functions that can take seconds to wake up. This means your middleware, API routes, and even some page rendering can happen within milliseconds of your users, regardless of where they are. The trade-off is that edge environments have constraints, smaller memory limits, no native Node.js, APIs, and restricted package sizes. But for the right use cases, the performance gains are dramatic. Next.js makes edge deployment simple with the edge runtime. To opt any route or middleware into the edge, you export a runtime configuration, export const runtime edge. This tells Next.js to run this code on edge functions instead of traditional Node.js serverless functions. Your middleware automatically runs on the edge by default. That's why it's so fast for authentication and geo-targeting. For API routes and pages, you need to explicitly opt in. The Edge runtime has important constraints. You can't use native Node.js APIs like FS or Crypto, you have smaller memory limits, and your bundle size is restricted. However, you get access to web APIs that work everywhere: fetch, URL, headers, and more. The key is understanding which parts of your application benefit from Edge deployment. Middleware, simple API routes, and authentication logic are perfect candidates. When should you choose the Edge runtime? Perfect use cases include middleware for authentication, redirects, and geo-targeting. These need to be fast and globally available. A/B testing logic that determines which variant to show users benefits from Edge speed. Simple API routes that don't need database connections or complex processing are ideal Edge candidates. Feature flags and content personalization work well because they're lightweight but need global performance. However, avoid Edge for data-intensive operations like complex database queries, file processing, or machine learning inference. These need the full Node.js runtime. The decision framework is simple. If your code is lightweight, doesn't need Node.js specific APIs, and benefits from global distribution, choose Edge. If you need heavy processing, database connections, or Node.js libraries, stick with the Node.js runtime. For e-commerce, your authentication middleware and geo-targeting should definitely run on Edge, while your product recommendation engine should stay on Node.js. Outstanding! You've mastered the power of middleware and Edge functions. You understand how to implement robust authentication using cookies and middleware, create intelligent redirects for better user flows, and leverage geo-targeting for personalized global experiences. You've learned when to deploy to the edge for maximum performance and when to stick with Node.js for complex processing. These capabilities transform your SSR applications from basic data fetching sites into sophisticated, secure, and globally optimized platforms. You can now build e-commerce applications that authenticate users seamlessly, redirect intelligently based on business logic, and provide localized experiences at global scale. You've completed your journey from Next.js foundations to production-ready Edge deployment. Let's wrap up with your key takeaways and next steps. Let's review your incredible journey. You started with solid foundations, mastering how Node.js powers Next.js, SSR, through the event loop, ES modules, and async operations, then building type-safe applications with TypeScript patterns for API routes and server components. You progressed to core SSR mastery, understanding the evolution from getServerSideProps to app router data fetching, implementing intelligent caching strategies, and leveraging streaming with React suspense for optimal performance. Finally, you reach production readiness, securing applications with middleware authentication, creating intelligent redirects, implementing geo-targeting for global personalization, and deploying to edge functions for maximum performance. You've transformed from someone who knows basic Next.js into a developer who can architect, secure, and deploy production-grade SSR applications that scale globally. These SSR skills are game changers for your career. As a front-end developer, you now understand the full stack, not just client-side React, but server-side rendering, authentication, and global deployment. This makes you invaluable for modern web teams. As a full-stack developer, you can architect complete applications from database to edge deployment, handling performance, security, and user experience holistically. For e-commerce developer roles, you understand the critical performance and SEO requirements that drive business success. Faster page loads mean higher conversion rates, better SEO means more organic traffic, and personalized experiences increase customer loyalty. Companies need developers who understand that modern web applications aren't just about code. They're about delivering fast, secure, personalized experiences that work globally. You now have those skills. Your learning journey doesn't end here. It accelerates. Challenge yourself to build a complete e-commerce product page using everything you've learned. Start with typed API routes and server components. Implement app router data fetching with intelligent caching. Add streaming for slow components like reviews or recommendations. Secure it with middleware authentication and deploy it to the edge. As you build, explore advanced topics like server actions for form handling, advanced caching strategies with ISR, or integrating with authentication libraries like Next.js. The Next.js ecosystem is constantly evolving, and you now have the foundational knowledge to master any new features. Remember, every expert was once a beginner, but not every beginner becomes an expert. You've taken the crucial step. Thank you for joining me on this journey to Next.js SSR mastery. Now go build something amazing.